My name is M. Richa Masha. My register number is URK17CS176. Today we are going to see experiment number 6, that is implementation of doubly linked list. So the aim is to implement a doubly linked list. Let's see the program. So in the main function I have given the choice that inserted front, inserted back, inserted position, delete from front, delete from back, deleted position, display from front and display from back. So the first case I've given it case wise, and then each case, in the first case I've given inserted friend getting the elements from the user that has to be pushed into the stack. So in each insert, position, delete and deleted last and deleted position, all I've given in switch cases. So let's see the program. Here I've created a structure that is for node, that is to add a node. Here I've given struct node star null next is equals to null, and struct node star previous is equals to null, and struct node star head is equals to null. So everything is pointing to null here. So I will open the class say doubly, and I will create a constructor simply, and then have a void insert at front and get the value as an argument. Then I will say I will create a temporary variable where I will create a new node using temp star temp, and I will store the data in the temp. Then if check if head equal to null, that is when there is no element, when there is just one element, that means temp's previous is equals to null and temp's next will be head, and head is equals to temp. This is when the stack means the queue is link is empty, and this temp previous is equals to null and temp next is equals to head, and head is equals to temp. That is then else if there is an element, if there is also already an element, then I will say temp previous will be equal to null. So this you are inserting at the front. So temp previous will be null and temp's next will be the head, that is the first node, and then head's previous will be temp and head will be equal to temp. So next is inserted back. So again we will get the value from the user. Then you will create again no node and store the data. Then have a temporary another temporary variable. Say temp1 is equals to head. That is first we will again check if there is no element, that is head equal to null. Then you will say temp previous is equals to null. Temp's next will be equal to head, and say head is equals to temp. Then else while temp, so you will use a while loop. Say temp's next is equals to null to traverse till the last node. Then you will put temp's previous will be equals to temp1, then temp1 will be equal to next. That is inserted bracket means previous will point to the last node and temp1 next will be pointing to temp. So now temp's previous will be temp1 and temp's next will be temp. Void inserted position is I will again create a new node, store the data and say temp1 is equals to head and get node number, enter the node number from the user. Then for I is equals to 1, I less than node number I plus plus, check if the node is present. So temp next is equal to null means the node does not found. Then or else you have to go temp equal to temp1 till next, where till the node number has been reached. Then temp next will be pointing to temp1 next, and temp previous will be equal to temp1. Now this temp1's next will be next previous, that is next pointer to the previous will point to the temp. That is the temporary variable that we are installing that node, and temp1 next will be equal to temp. Delete at front. Now delete at front is you will create just a temporary variable which is pointing to head. If head equal to null, that means the list is empty. You will return. Else what will happen? Else inside you will say temp1 equal to next null. You will say head is equals to null. Value from front is deleted, so you will delete the front value. Else what you will do is if head equal to temp's next, and then you will say inside this if condition, if temp's next is equal to null, that is when there is one element in the array, this will happen. Else what will happen is head equal to temp's next and head's previous is equal to null, the value will be deleted. Okay. Deleted last is again you will use a temp variable which will point to head, and say if the list is empty you will check head equal to null. Else inside the loop when there is one element you have to delete from the back, then you will say temp1 next is equal to null, head equal to null. That means see the first element, head is pointing to the first element, will be equal to null, then value will be deleted from back and you will delete the value. Else what you will do is you will traverse till the last of the node, that is while temp1 next not equal to null, it will traverse till the last node, that is temp1 equal to temp1 next. Then you will say temp1 previous next will be equal to null, then the value from that back will be deleted. Now deleted position, what you will do is again you will create a temporary variable and say temp is equals to next, then get the node number from the user, Then say temp next equal to null means then you will delete the temp, that variable, if there is one element. If there is no element, then you will say that head equal to null means empty. Else what you will do is you will traverse till the node number, and if the node number is not present, then you will put node not found. Else what you will do is temp previous next will be equal to temp next previous will be temp previous, and delete the temp. Display from front is you will have again a temporary variable that is pointing to the first element, that is head, and then if it is empty you will print empty. Else what you will do is you will traverse till temps next not equal to null and print each data. Then you will say temp equal to temp next, so it will go to the next element and you will print the data. Display from back is again you will check if it is empty, that is head equal to null, and else while temp next not equal to null you will traverse till the last. Okay, then from there you will print from previous. So you will go to the previous. Now you will traverse all the length from till the last, and from there you will traverse to the previous. So there you will print one data and it will come using previous data. So let's see the output of this program. Now I'm inserting a value at the front, say 5. Value is inserted in the list. Yes. Now I will insert it back. So I will insert 3. Yes. Now I will insert the now I will insert at a position. So enter the value. I will put 2. Enter the node number 1. Yes. See, I will show display. The elements are 1, 2, 3. Okay. So now I can delete an element from the list. The value from the front is deleted, and now if I give 8, it will display from back, that is 3 and 2 from back. So first it was stored 1, 2, 3, now it's storing 2 and back. This is the end of experiment number 6.